In this hands-on, we'll explore function composition in Python. Let's start with our first example, streaming log processing. The goal here is to compose functions to filter and format log entries. We start by defining a compose function using Python's reduce function from the functools module. This function takes multiple functions as arguments and chains them together. The key functions here are filter logs, which filters out logs containing error, and format log, which formats valid logs. The composed function process log applies both functions sequentially. The nice thing about this approach lies in its simplicity and clarity. It encapsulates the entire process of log processing in a single function, adhering to the principles of functional programming by maintaining purity and immutability. The result is elegant and readable code. Let's now head over to the genome pattern recognition example. In this case, we apply function composition to normalize DNA sequences and then search for a specific pattern. The normalize DNA function ensures the data string is in a consistent format in uppercase, while find pattern checks for the presence of a specific pattern in the DNA. A function is then composed with find pattern and normalize DNA and applied to the DNA samples. In our final example, to do with stock price anomaly detection, we're composing functions to detect anomalies in stock prices. The normalize price function normalizes the price, and detect anomaly identifies if the price is an unusual value. We then compose a function out of the detect anomaly and normalize price functions. A list of sample prices is then defined, and anomalies is a list that's populated by making calls to the composed analyze stock function for each price in the prices list. The anomaly detection results subsequently printed to screen. Let's now take things up a notch with some slightly more sophisticated examples, albeit not too complicated. With the first not so simple example to do with streaming log processing, we refine the log processing with additional steps. We're introducing a new function here called filter critical, which filters critical logs, and another function called extract message to extract the main message. The function process critical log is then composed from the extract message and filter critical functions. A list of logs is then populated with some logs to pass through the composed function. A new list is populated with calls to the process critical log composed function for each log in the logs list. And finally, each message in the critical messages list is printed to screen if it is not none. In the second not so simple example to do with genome pattern recognition, we include mutation detection along with pattern recognition. We'll normalize the DNA, detect a pattern, and then check for mutations. The function analyze DNA combines all these steps, showcasing a comprehensive analysis pipeline. We start with normalized DNA. We then find a pattern, applying that function to the normalized DNA output. We then detect mutations, passing in the normalized DNA, and finally return the output of the summarize analysis function, which accepts the DNA, the pattern found, and the mutation detected to compose a formatted message. The code block then goes on to define some DNA samples and create a new list called analysis results that is populated with the output of the analyzed DNA function for each DNA sample in the list of DNA samples above. Once the analysis results are in, they're simply printed to screen. Finally, in our last not so simple example to do with stock price anomaly detection, we incorporate some statistical analysis into our anomaly detection. We'll first calculate moving averages and detect anomalies based on statistical deviations. A new prices list is created, a new window size parameter is set to 3, and then moving averages are calculated by passing the prices and the window size to the calculate moving average function. These moving averages are then subsequently printed to screen. And finally, the anomalies list is populated with the output from the detect statistical anomaly function, which accepts price and average for each price and average obtained from prices and moving averages. Finally, when the anomalies are in, the anomaly detection results are printed to screen. So having seen all of these examples in action, you can see how they underscore the effectiveness of function composition in Python for various applications. And once again, even though we've used the realms of stock price anomaly detection, genome pattern recognition, and streaming log processing in all the hands-ons we've done so far, these implementations are very much applicable to any data processing task where a similar challenge needs to be addressed using such techniques. The moral of the story is that by decomposing complex processes or pipelines into simpler functions and then composing them, we can achieve clarity, maintainability, and extendability in our code. Thank you for your attention. And as before, I encourage you to download this Jupyter Notebook, play through the functions that are here, modify them to try different values, different approaches, different functions altogether, or to apply the techniques that you see here to a problem you may be facing or addressing in a completely different vertical altogether. The more you embrace the techniques, the easier it becomes to apply these techniques to any data processing task you may have on hand.